hand over the session and please continue, sir.
Okay. Uh, okay. I'm just sharing my screen now. Everybody, please. Am I audible to all? Let me know.
Yes, sir. Yes.
Okay. 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 Fine. So in today's session onwards, we will start with PCB design part of our STTP, right? Up till now, we have seen the Arduino programming techniques and how we can simulate by using the virtual platform, and what are the different interfacing ways by which you can interface different components with the Arduino, right? Then that was the concept. We have studied theoretic ways, we have done the prototype virtualization, everything, right? But the next step of any project whenever you undertake, that will require you should be have a knowledge about to make that kit ready to serve for the consumer, right? First you build the concept. Any design, when it takes place, the first step it is your vision, right? What you think about that circuit, what kind of an application you willing to give it to your customers, right? So accordingly you have to plan it, right? So firstly you choose the different type of component for your design. You try to make work with your circuit components, right? You try to simulate it. You try to get what will be the probable output of your that circuit kit or prototype kit you are trying to get in virtual manner. You can build it whatever on the basis of the knowledge what we got in the previous 3 days session. But after finishing that thing, after finishing those things, we can have a next step towards purchasing the hardware component and trying to implement that component on certain things which can have a physical presence over it, right? So we can fix it somewhere and we'll have that action to be get carried out, or the task to be get performed in a physical manner, not in that virtual manner, right? In a physical way world, we'll try to implement the things, right? And to implement those things, we require to have certain things to be carried out, or certain steps to be carried out, and that the first comes is called as an PCB design. So let us focus from today's session onwards on PCB design and how the PCB design is carried out. What are the basic fundamental things of PCB design? Let I take you to the content of my session for the day. That will be basic. We will try to understand basics of PCB design. We will try to understand what are the different software tools or applications are available for a PCB design, how to design a PCB and work with the different layers of PCB. There are various types of PCB layers are there, and according to that we have to manage the design of our printed circuit board. We will try to get certain introduction about one tool which is named as a PCB Wizard 3 tool, and try to make a sample circuit in that application, which is also application program. It is a very light version of a PCB Wizard for designing of a PCB compared to the OrCAD, Eagle and other tools. Why I have chosen this one is because this is the first tool I have ever used in my life whenever I have started my PCB designing as a career. And for the first sake, being an industrial electronics engineer as a diploma candidate, I learned to make small circuits in the academics. At that time, I started to sell some printed circuit boards and help my seniors, because I have grasped the command over the PCB manufacturing processing. So at that time this particular tool is become my one of the favorite one, so which is very easy for understanding for a beginner one, and it will help you a lot to carry out your entire process in a simple manner. So there is no hassle in creation of your first project of a PCB designing, and you can have a lot of things inside the PCB wizard. And once we get to know about certain designing software, which is at the basic beginner level, we will train our mind to understand the concept of high level software, or you can switch directly afterwards to the professional designing software. This is also a professional tool, but which it is very light version, and it gives a similar kind of an benefits which one need to have while designing the circuits professionally. So we will try to start our session for the day, and we'll try to understand what the PCB is, why do we need to have a PCB, and what are the different application areas where PCBs are playing very important role, and that's what we are eager to learn this PCB designing and everything, right? So how many of you have handled a PCB before, right? Whether you are student, I'm asking to majorly students, that how many of you have handled any PCB before or seen any PCB before having this particular topic of discussion, right? You have seen PCBs, right? We are surrounded by these things. This is a critical, you can say, very crucial and important aspect of our life nowadays, because whichever gadget, whichever devices we are utilizing nowadays for carrying out different tasks day by day, throughout the day, you can say, we have a need of a PCB, because without that PCB, it doesn't possible for the manufacturer to make those gadgets, right? Yeah, in childhood also we have started our kits to be get manufactured by a PCB. So whatever electronic cars or whatever electronic toys you are played with while in your childhood, they are also manufactured with the centralized PCB, right? Which is having all the control components mounted on that particular circuit, or you can say the plate. It is a kind of an plate onto which all the components or the circuit devices are mounted, whether it is a electronical or a mechanical parts, they are mounted on that particular board, and that entire circuit will give you the particular application which is it meant for, right? So we'll start with the textual context of this PCB design, and try to understand what are the components of these different aspects of these PCBs, right? Yeah, we have different components we have seen. Let us try to discuss few point about those. That is, let's say, they first of all have a look of how the PCB printed circuit board looks like. Let's say this is how the printed circuit board look like. This is not having any component mounted yet, but a sample. It's just a printed board. You can call it as like it's just a printed board, right? So it is having some electrical connective tracks and all those things. So it is termed as printed circuit board, right? So this is how simply it looks like, right? Other than that, now we are discussing and communicating over the internet, right? So definitely multiple components or multiple gadgets, multiple devices are coming into the picture, right? So in that case, we have different gadgets. So different gadgets requires different sizes of PCBs to be get utilized for making it to run, right? So the first gadget, with the help of which we are trying to get communicated over here, that is the first thing is a laptop or a desktop computer, right? So what is the printed circuit board inside the computer or a laptop? That is a motherboard, right? So a motherboard can be a large scale PCB onto which we have connected with the several components like CPU, right? We have capacitors, we have resistors, we have transistors, we have integrated circuit chips, that is ICs. We have a CPU planted over it, right? We have serial communication and Bluetooth or Wi-Fi modules connected onto that particular board, right? Everything is placed on that board in a proper manner so that it can perform that task very conveniently, and the user will get an access to that particular part by using that particular printed circuit board. So that is what I talked about is, now when we are using the computer, similar time you requires to have a charger for that, right? So to have that charging, there is a charger circuit. So that charger circuit is also manufactured by using certain PCBs, right? You are utilizing a keyboard, right, to give the inputs, right? So that in keyboard is also having a certain PCBs, type of certain PCBs, which is lighter in weight, right? So that is also one of the application in electronics where PCBs are used. Some of you are connected with the smartphones, right? So the smartphone is a portable gadget. Everybody knows we can carry out throughout, right? So that gadget is carried out. So that definitely it is a need of that gadget is to have a lightweight PCBs, right? So the very wherever we use the electronic gadget or any mechatronics based mechanical or electronic or electrical parts we need to brought together, we need to have a circuit as a part of that particular gadget. So that's the printed circuit board comes into the picture. Let us try to understand what is PCB basically. That was we have seen is nothing but a small kind of an description about a printed circuit board, where we can see the printed circuit board in a normal day-to-day life, right? But what is exactly the PCB in theoretical manner? So the printed circuit board, that is acronym stands for PCBs, are the foundational building block of a most modern electronic devices. What we can say is the foundational building block of most modern electronic devices, whereas the printed circuit boards are the foundation on which all the other electronic components are assembled onto. So whatever the components I listed just now, just like resistor, capacitor, relays, or you can say regulators, processors, integrated circuits, or the elimination of wire, for that there are tracks they have created, right? So everything is created on that particular plate of made of copper or any other material, right? So it will give us a circuit ready for us within a small area, which can have a lighter weight, right? So this is a basic term related to the PCB. So the examples I have given, basic major examples, what we have seen up till now is the computer which we are using, which is utilizing a board called as a motherboard or a main board of the system, or the development board which we have studied in the last 3 days, that is Arduino board, right? Our Arduino development board. It is also a best example of a printed circuit board, because onto which the controller and other input output pins are fabricated, and it is brought to us for everything, right? Now we'll come back and continue with the part of what is PCB. So basically semiconductors, connectors, resistors, diodes, capacitors, radio devices are mounted to and made talk to one another through the PCBs. This line trying to convey is, all the semiconductor devices, connectors, resistors, diodes, capacitors, active and passive components, what we have learned in our academics, that are brought together, placed onto a surface, and tried to connect with some copper track, or you can say some tracks as in wires, right? So this will try to communicate the information from, or information signal from one device to the another device, and make it to act right in the manner for which it is made for, right? So this is how these circuit components get connected with each other via the tracks printed onto the circuit board. The PCBs have mechanical and electrical attributes that makes them ideal for these different applications, right? Then most PCB manufactured in the world are rigid. Rigid type of PCBs are found everywhere, and roughly 90% of the PCBs manufactured in the today's world are a rigid boards, starting from the motherboard, coming back to the mouse, whatever used in the smartphones, whatever used in the electronic gadgets that are the majorly a part utilizes the rigid type of PCB boards, right? Right, which is having little a bit of weight, but compared to the other components and all those things, it is lighter in weight, right? But it is rigid one, right? So normally it can't quickly break that particular board, right? So it has a certain rigidity into it, right? Other than that, this PCBs, some of the PCBs we have seen around that are flexible in nature, allowing the circuit to be bent or folded into the different shapes, or sometimes they are used where the flexible circuits will survive hundreds of thousands of flex cycles without any break in the circuit. The rigid circuit cannot be flexibly bent, because if we try to do that, it will going to get break that one, right? And it will get diminished, or you can say it will not function properly. But over to which, after a year of research, some kind of and type of materials are used for making the flexible type of PCB, right? So the flexible PCBs are able to bend or get folded in different shapes. For example, if we see the flexible keyboards, if we have search onto the Google, right, you will find that there are flexible keyboards are available in the market, which you can roll out and carried out along with you in your pockets itself, right? Or you can say your hard drive cables, right? Or a hard drive connecting one. If you take out your computer hard disk, right? So in that you will find the foil type structure is there, plastic file type structure is there. So that is having a tracks printed onto it. That is the example of flexible PCB. Or if you don't want to go anywhere, you just open your computer's keyboard. You will find there that in between the key, below the keyboard keys we press, we'll find 2-3 layers of plastic, right, which is having some black dotted design over there. So that is nothing but also a part of a flexible PCB, right? Along with that, our smartphones, if we open, right, some of the parts are connected with the flexible, majorly the displays are coming up. The display data buses are manufactured by using the flexible PCBs, right? So they can be have, yeah, chipset processors are also have make use of this kind of and flexible PCBs to be get used, right? So wherever there is a much lighter weight or wearable gadgets to be get manufactured, the flexible PCBs are utilized. But this kind of an PCBs comprises roughly 10% of the market. Whatever gadgets we are utilizing these days, though it is becoming so larger these days, but up till now it is nearly about 10% part of the this market is captured by the flexible PCBs. But major of the gadgets are manufactured by using the combinational part of a rigid PCB and a flexible PCB, right? Making the flexible PCB at home, or you can say at your own lab, it become little bit of a tedious process. But having that imported from the professional manufacturer, it is always possible, right? Most of the industries gives you the provision that you can make your gadget by using the flexible PCB. But in case of your own setting up your own laboratory and to have a PCB manufacturing to be get carried out, the rigid PCBs are the only ways where we can do that task very easily with the very cheap cost, and it will give an access to that entire things can be carried out very easily without any kind of a difficulty in manufacturing those PCBs. For just we need to have a clear understanding about the designing part, how the schematics are made, how the components are placed in the circuit diagram, what are the different components and its symbolic representations we need to understand, right? Because these 3-4 things will be matters a lot when we talked about this PCB manufacturing process or a fabrication process. So to undergo on this particular process, you need to have understandings about the different symbolic representation of your components which you wanted to utilize for your design. I'm repeating this. Whenever you wanted to make any circuit board in the hardware form, you should understand the symbolic representation of your circuit components to make a design ready for your PCB. So from there your journey will start, and for making those things you require certain software to be get utilized, right? So later on in this session itself we will try to understand the different parts of this particular PCB manufacturing process, and we'll start with the understanding of the conceptualization of a PCB design, so under which we have seen up to this what is the PCB term stands for, and what are the different things of PCB. In that there are various types of PCBs are also there, that is a single layer PCB, double layer PCB, or a multi-layer PCB, as per the requirement of different applications that we will see in afterwards, right, in detail about what are single, what are double layer, what are multi-layer PCB, and how to make use of as per the requirement of applications, right? But the major focus of us for this session is to have a working with the single layer PCB as a part of our curriculum, and for the need of prototype designing, majority of things can be carried out easily by the use of rigid type of single sided PCBs, right? So why are the printed circuit boards used? Compared to the traditional wire circuits, PCBs offers a number of advantages, right? I'm reading that line first once again. Compared to the traditional wired circuit, PCBs offering a number of advantages, right? Let us consider you are at the first stage of your project designing. You are about to be in a first stage of your project designing. While working in your laboratory, while testing your components, you carries out those circuit, implement that circuit on your breadboard. Yesterday in the virtual simulation, we have seen the breadboard onto which we need to make use of certain wires for making the connections with the other components. Likewise, in the physical manner, we need to use the breadboard and the components to be mounted on that breadboard by using that holes created on that breadboard or available on that breadboard. And correspondingly, wherever it is necessary, we need to additionally utilize certain jumper wires or some railing wires to make the connection from the one end of the component to the other end of the component. So making use of wire becomes more difficult to understand where the connection goes when it is having larger number of components are involved in our circuit design. For a smaller circuit, it is always possible to carry out that prototype design and everything with the breadboard, right, or a general purpose PCB design, but it involves the wiring, right? It involves a lot of number of wires to be get connected with several components, and that is the one thing which is making it complex to understand. And if any of those connections get loosened up, then the PCB will not work properly, or the circuit will not going to work properly. What to do in that case? So to have ensure about the correct working of your circuit design, or whatever connections you have made, that should be very unique and it should work redundantly, we should have make use of PCBs for a longer duration of time. Because at the time of a design part, making use of wire for testing purpose, that's okay, because we can make several changes as per the functioning of the circuit, and we need to carry out certain tests. So that is till that time we are not so aware about what exactly the tracking should be. But when you wanted to deliver that project to somebody else, or we wanted to give that particular gadget to the customer, at that time you cannot give the wired gadget to a customer, because it may get problem after certain kind of an issues if we get falls onto the earth, or you can say if it gets open, it becomes difficult for a user to get closer with that one, right? If any wires get short circuited, that then definitely that will create some trouble for a user to have an utilization of that particular board, and several times it need to be get maintained, make a maintenance of that. So they definitely, if we are using that any of the part design and deliver to the consumer with the use of several number of wires, then it will adds up maintenance cost for several things several times, right? So instead of doing that, and it will also adds a little bit of wires weight onto that particular board, more number of component integrated onto that circuit, that will adds up the little bit of weight on that particular board, and the circuit becomes more heavier compared to the PCBs which are manufactured by using tracks. So that is what the necessity of manufacturing PCBs comes into the picture, and this will give you a number of advantages over the traditional manufacturing process, right? So that's the aim. People are switched from the regular connectivity by using wire to the ready-made PCBs, or you can say a fabricated PCBs board for utilization of their project design. And that's the term the Arduino comes into the picture, right? Because let me try to explain by the example. Let's say we have two example cases. We have studied microcontroller in our academics, right? And nowadays we are working with the Arduino, right? So while working with the microcontrollers, the chip is integrated together with the different input output peripherals on the single chip, right? But for a necessary purpose, we need to make a reset circuitry additionally. We need to incorporate input output peripheral, additional input output peripherals with the help of certain boards and cables, right, to work with, right? And it becomes that circuit become little bit of more complex, and sometimes if we made the wrong connection, it may harms our devices also, right? Whereas that Arduino community people think over it, and they try to reduce the time of the manufacturing and designing of that any of the prototype process. So they come up with the development board, onto which they have plotted the microcontroller itself. They have taken out the input output pins for a user to get access by using certain additional male to male or male to female wires, and they can directly put their input output devices with that development board. So additional time which is required for a fabrication through a central processing board will be get reduced. And that is what the Arduino development boards or other development boards, which are the variants of Arduino family or any Arduino community, becoming so popular that the nowadays the users are preferring those things for their prototype designing. So you can see that see the progress of manufacturing world in the printed circuit boards, right? So it takes the wiring concepts to get decreased, and the ready-made printed circuit boards get increasing day by day. Nowadays use and throw boards are also coming, right? So in that case, you can't reuse that particular board because they have designed so small, and complex tracks are made onto that. It can carry out those small application. You can test it over it, and you can, after that, if you wanted to make use of further, one time you can make use of those things, and then you can destroy it, or you can throw it onto your if it fails, then you can't repair those things, right? So these are many things are there in this are available, right? The smaller and lightweight design is appropriate for use in many modern devices. This is the best one part of any design, because when you let us try to understand with a small example for this, why it should be small and lightweight. Let's the best example of this is your smartphone. If your smartphone is too big in size and having a higher in weight, or you can say heavy in the weight, is it possible to carry it in your pocket? Answer my question in my chat box. Is it possible if your smartphones are more heavier than the current way, right? So is it possible for you to carry out in your single hand or in your pocket? No, definitely not. You can't carry your smartphones everywhere, because it becomes very difficult for a user to carry it and talk it onto your smartphone or work with the smartphone, right? So the size of the device or size of the gadget matters a lot as per the requirement of carrying it from one place to the another place, right? So this leads to a lightweight design of a system. This leads to a lightweight design of a system, and smaller area capturing is required for that. So that leads to have a lightweight designed PCB boards, right, for modern electronic gadgets. So the best example is our smartphone, or you can say nowadays the tablet computers are also coming, right? Tablets are coming, right? Before smartphones there was a tablets was there, right? After computer and laptop, tablets is a new age of technology which have some computerized similar kind of an features, which was then taken out to smartphones, which where we can also have a communication onto the same, where we can have an accessibility to the touch screen, right? So it becomes very easy for a user to provide the user access, to have given the portability, also lighter in weight, smaller in size, right? Also battery operation can be carried out into that. So definitely it adds more advantages when the design is concerned with certain points to be get considered, right? So more advantages you need to provide to your consumer, then definitely this kind of and things comes into the picture while thinking about the design of your product, whatever product you might be thinking about. Let's say while their reliability and ease of maintenance suits them for integration in complex systems. Let's say let's say there is a keyboard, traditional keyboard, right? So in traditional keyboard there are several number of keys are present, right? So there are several number of keys are present, and if any keys got failed, right, you can replace that key by there, right? But the printed circuit board which is there at a controller part, right, which cannot be easily replaceable, right, because it comes from the manufacturer and they have certain kind of an design over there, right? But if we have let's say example of any gadget which is for let's say smartphone, let's say nowadays they're coming up with the smartphones, right? The smartphones are not so required to have maintenance, additional maintenance need not to be get done for several years, because it lasts for more than 2 3 years, right? So they are more reliable compared to. But in case of keyboards, the many of the keyboards keys get burnt out, or you can say taken out, or broken or something like that. It start to get some kind of an errors into if gets loose up on from the board, right? So these kind of an issues are faced with which leads to the reliabilities and ease of maintenance, right? These two terms are very important in any of the design. Your product should be reliable, as soon as well as it should be have very low maintenance, and it should be very easy to maintain, right? It should not lead to more expenses on maintenance, right? So because user will not make use of those things, right? The another best example I would like to add into this is a television set. Earlier it was your CRT monitor and CRT displays were there in the 90s or 2000s, beginning of the 2080s, 90s and 2000s decade, right? So at that time the monitors are the display devices are very bigger in sizes, and the boards are also bigger in sizes inside them. If you have might have opened your television set in your home, right, you might have seen that it is bulkier in sizes. But later on the technology comes with nowadays you can see it is coming up with the very sleek and slim, yeah, definitely in the old technology is called as a dabba TV, right? Somebody is talking about those things, right? Okay, so nowadays we are getting a smart TV or a slick TV or television, flat monitor systems are available with these days. Why this is become so popular, and why this is made possible for that? Just because of printing board technology, and that makes it possible for this electronic manufacturer to manage several components to bring together on a single board or multiple smaller boards, which can incorporate together and functions with the as a essential part, and they will provide you the essential advantages they wanted to provide to the consumer of that particular unit. right? So that is what. And additionally, their low cost of production makes them a highly cost effective option. If you wanted to make a printed board, or you can say general prototyping by using a wire, several expenses are there. But if you go for a printed circuit board, they are considerably, if you go for a mass production by using PCBs, it goes very low cost production, and it saves a lot of money on this particular manufacturing. So definitely it's always a best choice to go for a PCB design for having and cost effective solution for device designing and manufacturing of any gadget, right? So what are the different industries which we can talk about, which are using the PCBs then, right? We have seen the different gadgets as an example of theoretical process of PCBs, where we can see the PCBs. But what are the different industries then which we provide the which provides the different use of these PCBs for a majorly for different applications, right? So let me try to see what are the different industries are using that PCBs, and how they are using, and what type of PCBs they are trying to make use of, right? So basically the first that we talk about because as of now the first one industry which is nowadays in very boom because of the COVID-19 emerges in a very large manner. This particular industry is now trending, right? You can say a lot of things are happening in this particular industry now. A lot of researches are going on into this particular industry, right? So this industry requires certain gadgets, electronic gadgets, to be supported to provide a ace of simplicity in making a treatment, right? So in that, the electronic computers, imaging systems, MRI machines, radiation equipment, and containing advanced technologies are getting emerges in day by day process. Biomedical instruments are getting emerged daily, right? So that requires a lot of electronic circuits to be incorporated for having a smaller occupation of smaller area within the premises of your hospitals, or you can say your ICUs, or wherever the medical treatments are going on for the testing laboratories, right? They need this kind of a medical electronics, and that working of that medical electronics is controlled by certain electronic gadgets, or the functioning of those devices are controlled by electronic gadgets. And at that time, you should have a reliable nature of your system, you should have a lowest cost of your system, you should have a low space occupation of your system, very important, as well as the you can say design of your system, portability of your system matters a lot. Nowadays you might have seen one example of a best example of your kit, that is infrared temperature measuring gadget, right? How many of you have known to this infrared temperature measuring gadget that seems like a gun, right? Many of you might have seen in the television also, because in nowadays it is becoming more popular, right? So why it is? Because it's a non-contact type of device. Infrared, through infrared it is trying to measure. So to have a hand holding, right? And so that the user can lift it to certain height and carry it from one to another place, right? It is very needed to have a portable design of that, so that the user can make use of those things, right? So this is other than that, thermometer, a smaller digital thermometer, right? Which is a very bigger example of this, which is very small in nature, having a small coin type of circuit inside, fixed inside it, right? So that is how the particular industries is dealing with different type of PCBs. So in this particular industry, majorly smaller rigid PCBs, double-sided PCBs, or you can say earlier it was single-sided rigid PCBs and double-sided smaller PCBs with the SMD components are utilized. But nowadays these kind of systems are replaced with the combination of rigid and flexible PCBs. What I am saying is, nowadays this medical electronics field is emerging with the combination of several rigid PCBs as well as certain flexible PCBs combination. So they are making use of two different type of PCBs for manufacturing of their electronic gadgets. right? So this is how the basic medical industry making use of these PCBs. Continuing to this one, the thinner and smaller the size of the flexible and rigid flex PCBs allows for the manufacturer of more compact and lightweight medical devices. What I told is thinner. The flexible PCBs are coming in thin manner, and also it occupies a small sizes. They are flexible, they can be bent, right? So occupies a smaller space, right? It is, and some of the rigid flex PCBs are also can be utilized with that. Along with that, that makes the manufacturer or the designer of that particular project, that particular gadget, to make a choice whether to which particular PCB to be used as per the application, right? For example, the hearing aids which we use for your ears, pacemakers in your heart, right? Implantable devices, right? Many of the implantable devices nowadays are in the market, right? So as per the devices requirement, or you can say the cameras which are used for surgical purposes also, or in you can see in your integrated cameras in your smartphones, right? Or any computer systems, right? They come up in laptops, especially you can see the integrated webcams, right? These are the things which come up with this kind of a tiny PCBs or tiny modules or flexible kind of an PCBs, lighter weight PCBs, smaller design PCBs utilized, right? So the rigid flex PCBs are particularly ideal solution when looking to decrease the size of complex medical devices. So as they eliminate the need for flex cables and connectors that take up the valuable space in more intricate systems. That means what? Instead of using wires with the rigid PCBs, making use of flexible PCBs are more convenient, adds a more advantages in design. So that is what complex circuits are designed nowadays by using the combination of rigid PCBs and the flex PCBs. It's a combination of rigid plus flex PCBs. Going ahead with that, the most popular industry that everybody likes about, that is aerospace industry. That is a more the lighter weight is the most first preferences are given, right? Lighter weight is the most essential part of this particular industry. Your whatever parts utilized in this particular industry are designed with the constraint of with the consideration of lightweight and low space occupation, right? So rigid, flexible, and rigid flex PCBs are commonly employed in the aerospace industries. For the instruments panel, dashboards, flight mode controls, flight management systems, and safety systems are designed by using this kind of an PCBs. The growing number of advances in the aerospace industries or technology have increased the need for smaller and more complex PCBs for used in the aircraft, you can say in satellites, in drones, and other aerospace electronics. If nobody have seen the aerospace area, then you can have seen the example of drone as a minimal project of smaller aircraft. You can say a small flying gadget that is known as a drone. In drones, we have certain limit of carrying the weight over it so that it can fly easily, right? So definitely lighter weight, smaller size, thinner in design, it and smaller occupation of the space is very mandatory. So definitely this industry also needs this kind of an PCBs to be get utilized for their designing purpose. Though we can have that older age PCBs can be utilized, double sided or single sided or multi-layered PCBs can be made use of, but having use making use of flexible and rigid combination with a smaller area will make that particular gadget so reliable in operation that the user can make any further changes with respect to that by making a smaller changes into that, and it is also maybe upgradable with the certain aspect. If you put it inside the design you have taken care while manufacturing that particular gadget, right? Other than that, this aerospace industry are using flexible and rigid flex circuits, offers exceptional durability and mission survivability due to the elimination of connectors. Now we can know that the connectors cannot be utilized in this kind of things. In older days, there where they are using the connectors, but utilizing the connectors everywhere, it is not a reliable option, right? So wherever we requires to survive longer time, because the missile needs to be get survive for a longer period of time. Then durability of this aerospace in aerospace or craft is very essential for fighting planes and everything, right? Because in any cases, if there are connectors and everything are used for loose parts are used, that may get dismantled, and that functioning of that particular gadget may get loose, right? So definitely we need to have durability and mission survivability of the gadget. So definitely considering those points, flexible and rigid flex circuits or a combination of both plays a very you can say very important role in designing of the aerospace gadgets, right? So that is what some of the industries majorly playing very important role. After that, we'll go ahead with the another industry that is very popular, that is a you can call as military sector, military area, right? In the military sector, the most impacted part of this is PCBs are used in equipment frequently exposed to heavy impact, because in military sector the rigidity of your design or vibrational applications or shock absorbance things of vehicles or different military vehicles, or you can say rigidized computers or modern weapons and electronic systems just like robotics, guidance systems or targeting systems. So that this kind of systems are very crucial in military section, right? So for having a designing this kind of a part, because they don't know where exactly they need to place this particular design. So the consideration is while designing the military circuit is it should be able to bear the heavy impact, shock and vibration applications should be capable of to withstand to the heavy shocks and vibration produced, and military rigid computers, right, or weapons, right? So definitely these kind of best examples are robotic guidance systems and targeting system, radars, different radars are there. So these kind of or you can say submarines, right? So these things are playing very important of PCB designing is necessity in this particular field, right? So they have different areas of application, and as per the requirement, the majority of the field professionals are choosing the one of the type of PCB for their making manufacturing application, a different kind of an application as per the requirement. Other than that, processing industry, or you can say either it could be a food processing industry or a commercial used for any kind of an industrial work is going on. In that, the automation machineries are there, right? So in that automation machinery, different type of environment is there, and they may have to bear for different kind of situations. So the use of PCBs in industrial and commercial electronic has revolutionized everything from manufacturing to supply chain management, increasing to information, automation, and efficiency. So in industrial and commercial part, three parts are very important. Three particular things are considered for carrying the information throughout. It should help to automate the things and make it efficient to process, right? So these three advantages to be get achieved, in general they are a reliable means of directing equipment in increasingly automated facilities, enhancing production while decreasing the labor cost. How this can be achieved? Let's talk about. Let's say you are running a small firm which is requiring 1,000 people for performing any of the operation. So instead of that, if you replace that particular thing with a few of computers, which can at least one computer can perform let's say a work of 100 people, so 10 computer can have are enough, and the space required for placing the 10 computers is always a very low, right? Or we can say we require very less space to put that 10 computers and 10 users instead of having different 100 users for that applications, right? So this becomes very eminent for an industrial and commercial point of view to have the reliability of operation of that particular circuits, and utilization of lower space, and performing with the high efficiency and increasing the automating facilities for different processing units. We have seen the car manufacturing. Let us say take an example of automobile industry, which is very common in industrial processing, you can say. Earlier in 60s or 70s, or you can talk about in the 60s, 70s or 80s, the car industries, car manufacturing industries are using the labor for connecting the different parts of car and making one car ready. So it takes a very long process and long time to fabricate one car or manufacture one car. But as soon as the technology gets evolved and the evolution takes place in this kind of an manufacturing and control process, or automation takes place in this kind of an industrial sector, they come up with the electronic involvement. And at that point, the number of users required to operate the machineries, or to have that robotics introduced, right? And that introduction of robotics becomes so popular that they have removed the cost of labor, right? Because one robot is capable of doing the work of 100 men, right? So it becomes very easy to manufacture car very faster compared to the very old days of manufacturing the single car within 3 to 4 months. Right now, the per day 3 to 4 thousand cars are manufactured in a plant, right? So this is how the industries are growing with the help of new age technology, and that new age technology is built on this technology of called as a printed circuits, right? Because they are very reliable, very redundant, very efficient, low space carrying devices, as well as portable aspects are also can be achieved by using the help of this particular technology. So what are the different part? Then flexible and rigid flex PCBs enable manufacturers to produce increasingly smaller and lighter products. So the part required for a plant is, earlier it was to work with the manpower, they requires a larger space, because there should not be any accidental event should not occur with the complex environment. So there definitely, as soon as the machine and humans are involved into the place, the plant size is also becoming a part of complexity. So as soon as these electronics will get involved into, it becomes very easy to carry out this operation into the smaller place with the lighter product, and greater functionality can be achieved, because efficiency of a human can be get disturbed with this psychology, but the efficiency and functionality of a computer system cannot be get disturbed easily until and unless the input provided to the system becomes wrong, right? So humans are erroneous, whereas the systems are errorless, or you can say much lower error can be found in systems. So in many of the industrial purposes, drones, cameras, mobile electronics, and rigid computers can be part of accessibility, where they require these things to be get different operations to be carried out, right? So what are different custom printed boards are? Nearly all PCBs are custom designed for their application. That custom means basically as per the user requirement, right? How they wanted to have input sides to be get accessible, how they wanted to give the insider access to that particular board, right? So whether simple single layer rigid board to have highly complex multi-layered flexible, or a rigid PCB flexible circuits, PCBs are designed using special software called CAD designing, right? Now in that case, let's say a computer aided design, you can call as CAD is basically a computer aided design. So that is, everything is designed inside a computer, and then it is sent it to the fabrication unit, and that fabricating unit also automized to make that PCB. Earlier it was made handmade PCBs was there, but nowadays the industrial processing is carried out for manufacturing of a larger number of units at once. So it becomes very easy, very, and it is very convenient for a manufacturer to have a larger number of manufacturing of several units, several parts, several components at one particular plant, right? The designer uses this software to place all the circuits and connection points called as wires throughout the entire board. What this particular line is trying to say is, the software what I'm talking about is basically a CAD or computer aided design. It may be comprises of different softwares. What I talked about, PCB Wizard is also one software, OrCAD is also one software, you can say Eagle Professional Tool is also one of the software which provides you, give the provision to make a schematic, take a layout, send it to the printing and make the design, right? Easy ADA is also a software can be utilized for. Many are there. It's depending upon the user to user which to be used for their application of designing as per their knowledge and accessibility. They can have access. Express PCB is also there, which is also available on the internet to download, right? The software knows how to place each component, need to how that component should interact with each other, and any specific requirements as well, so such as how they need to be get soldered to the PCB. The system knows everything. You just need to place where you wanted to place that component and make choices for that as per your application, right? So different applications may be designed in this that particular software and sent it to the fabricator to get that fabrication done, or some of the PCBs can be manufactured at your home place also, right? So there is no restriction on the choices of user. Your particular PCB is of very not so complex in design. It's easy to understand, or you can say smaller that design is, and easy to understand design is there, or you requires to have a single layered PCB for manufactured for yourself. Then you can do it at your home also by making a small amount of setup in your laboratory at home, right? That can be easily carried out with some sort of solution liquids and some kind of an you can say component you need to have at your place, and then can be manufactured easily with a low cost. But if your circuit design is too complex and it requires a highly efficient type of designing, then you can make your design in your software. You can take export that design to the fabricator. You can send that design to the fabricator, then fabricator will manufacture that particular board for you, and you have to just pay few of that dollars or few of the rupees, some rupees to them as a fees for manufacturing, and you will get your complex circuit board ready for yourself. And now it is up to you whether to manufacture the single layer PCB or double layer PCB, or you wanted to go for a larger scale of fabrication, right? So there are various sites are there which are providing this kind of services of and provides the home delivery of your gadgets on online through e-commerce platforms, right? Yeah, we are definitely going to see the PCB design software, how to work with PCB design software. But before going to the PCB design software, I wanted to tell you how this particular PCB concepts are, what are the theoretic concepts behind the PCB, right? I tried my level best to put those content theoretic as well as practical together, so that you will not get so bored while listening to this, and you'll have a clear basic understanding about the PCB designing, or any other session I have conducted for Arduino also. I've tried to put this concept so that at least you will get an exposure about what the things are carried over in this particular area. So once you get to know what are the things are, how they carried out, you are ready to make use of that technology for yourself. And the thing required to go enhance your skill is a practice, right? I can show you, I can tell you that concept, I can teach you the practicals, but you need to practice it more and more daily basis. You have to practice it throughout your academics, so that there is no need to go outside and pursue any additional courses for getting the job, right? In nowadays, you know that there are very lesser jobs in the market, right? So very necessity for a user to become a self-independent these days, right? So how to become a self-independent now? So understand, have some skills with you, and if you have a skill, you can get job easily, or you can say either if you go for a job, or you can start your own startup also, right? For doing any of those two applications, you need to have certain skills in which you should be very good at, right? Until and unless you are good at something, nobody is going to ask you for work, right? And you if until and unless you won't work, you are not going to get paid for, right? So how to get survive then? Basically, the need of time is to have yourself skilled, right? So try to get skilled, try to understand the things when in a nice manner, try to understand the things in a clear manner. Whatever concepts are I'm telling you nowadays, or somebody else is sessions also you are attending, try to put your 100% mental presence into that. That will only help you to get through, right? Everything is available onto internet also, but the necessity is you should spend some time onto that, right? So the basically the printed circuit boards are manufactured by using certain kind of an material, right? So some of the top materials they are utilized for fiberglass, or you can say plastic substrates are there. The fiberglass you can see it's a green color copper clad PCBs are coming, or a plastic material is basically copper clad is the best example of that, right? So the fiberglass majorly found in the computer motherboard systems and many other applications areas where the rigidity of the board, unbreakable boards you can call, right? Whereas a solder mask is another kind of an layer which is added onto the printed circuit board, and then nomenclature ink which is used for the printing of the design silk layer onto the PCB. So different things are there in day by day, and up to next 2 days we will see the different things about the PCB inside, right? We'll try to put as much as possible into this, right? Continuing to the printed circuit boards design, PCB comes in a variety of designs, so it is important to have through understanding of a design process, because different PCBs come up with the different designing, right? And for that understanding of the process, some of the key elements to be considered when designing a PCB. Yes, it's not like that I wanted to design a PCB, let I start use the software and I started designing and I have made some layout and I have fabricated. It won't work. Anything or any process, whenever you wanted to carry out something, you have to carry out certain design aspects of that, right? So what are the different aspects you should know about before going for a PCB design or PCB fabrication or PCB area to do that certain things before going into the actual fabrication of that PCB. You should think about these few points before going into the fabricating of that particular PCB, or which particular software need to be carried out for manufacturing of this application, right? What I need to do is, the first thing I should aware of is application for which the PCB will be used. Let's say you are a student. Let's say you are a student and you are making a project called a flying drone, which can carry the weight and which can pick up some object and drop it to somewhere, right? Pick and place drone, you can say. This is the project area I have given as an example. So application for which the PCB will be used is for drone, right? So it adds the different things into this, because it is a drone, so it should fly. So the lighter PCB should be there, and it should be lighter. That means more area of that PCB should be as smaller as possible. So that 2 point comes into my mind, right? You have to consider while designing the system, you have to take care of that your PCB size should not get more than the required of your drone size, right? Because it requires some more power to lift. Then if the weight increase, then more power will be required to lift the weight. So for other than that, environment in which the PCB will operate, let's say, and if the drone is going to get travel over different parts, right, different areas, then different environmental conditions will be there. In that case, your PCB, whatever things you are mounted onto the PCB, that should not get affected. So different areas, or it may fall into the water, it may be probability, right? So it should be too rigid, or you can say it is environmental condition withstanding, right? And accordingly your circuit should not get damaged if it is used for military applications, right? So accordingly you have to think about. Then amount of space and configuration required for installation. Let's say, what is the space required for making that or placing that particular design onto the circuit, and how that circuit is going to get installed. that need to be get think before getting into the design part, right? Where to be place the screws for that, where to have that components to be on which particular side, whether the double side is double sided PCB is more required, or a single side PCB, or a flexible PCB. You have to decide, and you have to think about the final product, right? How the final product is going to look like. Accordingly, you have to think about the PCB's design. And the fourth point is the flexibility of the PCB. uh, do you want that PCB, if gets molded or let's say bent, it should be reliably work afterwards also. So in that case, you have to think about, let's say example of keyboard, right? Example of smartphones, example of the hard drives, right? Where the flexibility of that particular PCBs are also plays a very important role. And the fifth point is installation and assembly. The PCB design, whatever you have carried out for a certain purpose, it should not be too complex to install by for a new user, because you are designing certain part of product, you are delivering to the consumer, and if it goes very difficult for you user to get access to the ports, it become very difficult for them to make installations at their places, right? Assembling that part together, right? For example, let's take a part example of motherboard. Your computer manufacturers have made the computers for you, and you have purchased a computer. Let's say if your computer is not made your motherboard so that the rear part is giving you the port accessibility, where you connect the VGA port, where you connect the USB port, where you connect your keyboard, where you connect your mic, right? And in the front side, they have kept you the additional USB ports, hard drive access, everything. If this kind of an designing and assembly is not kept in mind, is it possible for you to get assemble your PC very easily? Tell me in the chat box, yes or no, right? Because these are the things which one should know, one should aware of before going for the any design, right? So don't be in rush of making a design. Try to understand few points. I'm not claiming that I'm teaching you a rocket science, but the core concept which one should understand, the concept of what basic things, because there are no formulas in between, right? But the things which I have talking about are very important before going for a designing, right? And once you know and have a clear cut understanding of your design, your view of the design get clear, you are very free to make a design of your PCB and make a layout of your PCB in a easiest way, right? So this is how the things can be carried out for a printed circuit board, right? Selecting the right PCB design to suit these considerations significantly impacts manufacturability, production speed, product yield, operation cost, and lead times. You should take care of these things. If you are making your let's say you are making academic project or a small mini project, you should not go for fiberglass based PCB, epoxy PCB, that will be of high cost. You can choose a copper clad or general purpose PCB for that. It will save your money, right? Because it may offers you a testing purpose, whatever requirements are there, they are providing that things, right? If you are making let's say a smartphone, in that case double sided PCB is mandatory. Otherwise what will happen, the size of the phone will become so larger, right? And the components requirement or placing it will becomes uncomparable, right? Unmanageable for you, right? So that in that case you are making a design of a smartphone, definitely a double sided PCB or a fiber glass PCB or a rigid flex PCB is mandatory to take into the picture, right? Like that. Production speed, within how many days your PCB should be get ready. Let's say you are working in any industry where the PCBs are manufactured, or you can say the products are manufactured, right? And you are manufacturing a product, or let's say a latest smartphone is launching about to in July, or let's say August. Let's say upcoming July or August, they are planning to launch the product, and before that they are working on to the design is ready. Now it's a part to manufacture that particular product. So what type of PCB need to be get utilized? Let's say the PCB manufacturing, which is requiring at least of more than the desired time, and number of products should be get ready. Accordingly, we have to choose the PCBs in which the lesser number of days are required to fabricate, so that the PCBs can be ready easily, so that the number of devices, number of gadgets can be number of desired gadget of that smartphone can be made in that available time, and it can be tested. Because if it is easy to test that device, definitely it is going to get market easily, right? Because if it takes a lot of months in that process, it will add up into the production slow, right? So definitely we have to think. Then operation cost, what is the cost we require for that, whether it is a budget or pocket friendly or not. You are making a project, but your PCB manufacturing processing is requiring 5,000 rupees. Is it worth for you? Because your product is going to sell at 200 rupees or 500 rupees, right? So lesser number of days required for the fabrication, lesser number of money required for the fabrication, and lead times, right? So what is the basically sell time which need to be get, right? So definitely you have to consider all the aspects, 2 3 aspects what I have discussed now. You have to consider before going into the actual designing of your PCB, right? And now I have done up with my parts of this. So basically let me try to understand what are the different softwares that are trending and commonly utilized by the professionals for their PCB designing part, right? Or schematic designing or layout designing. So the first one is the PCB Wizard, second one is the OrCAD, and then it is third one is the Eagle PCB Design, fourth one is the Tina Pro PCB Design, or etc. are available. Other than that, there is one more is there, Express PCB is there. Yeah, Proteus you also can make use of Proteus also, right? That is also providing you the provision of making the schematic as well as the layout of the PCB. That is also possible. But at the beginning of this conceptualization and understanding, at this particular beginner level of these things, you should start with the basic software. You should start with the basic software, as I told before. Once you understand these things, it may be get clear for you to have an impact of complex circuitry and complex designing get practice a lot more times. You can switch it to the professional version, because that professional tools will give you the lot of you can say features which will save your time, and cost cutting in your labor cutting also can be achieved by using that thing, right? So definitely these are the certain aspects of any PCB design process, right? What we have seen for the day one for a PCB, right? So these are for theoretical concept. Later on, some more theory is there relevant to the PCBs. But as we go on into the depth of the PCB designing, we will try to understand that particular theory as per the requirement of time, right? So for this particular session, these are the parts which we need to understand as theoretical way. So let us try to see how the circuit looks like basically, right? In my slides, I have tried to put some sample circuit over here. So you can say there are two diagrams here in this slide. There are two diagrams in this slide. The first one is called as a schematic, or you can call as a circuit diagram of your project. And the below diagram is nothing but a printing layout of your PCB, printed layout of your PCB in a real world, printed layout of your PCB in a real world. Let me tell you, this design I have made in the PCB Wizard, right? Which I am going to demonstrate you in this session only, right? So basically, this design can be made to view different aspects of a process, starting from selecting the component, right? Placing the component, connecting the component together as per the requirement of conceptual circuit diagram that need to be ready for first. And after that, we go for layouting, that is making the tracking and everything. And once the tracking and everything is done, we go for auto routing. And once the auto routing is done, the PCB is get ready. Then we can go for visualization of components, how they look like onto the board. So that is how this particular diagram will demonstrate you how the things are stepping from. This is the step 1 and this is the final step. This is a step 1 and this is a final step, right? So many things are there to be get carried out. Let me try to understand those things, and before going into the software, let us try to revise it once. If any doubts are there from your side, please ask in the chat box, so that I will try to answer it, and then I will take you to the software where I can teach you how to make the circuit, and how we can see the real world view of your circuit design, right? Is there any doubt in your side in understanding the today's session? Please let me know in the chat box. Okay, I hope many of you have are clear with your doubts, right? Great. Okay, so okay, let me go ahead. I will share my new screen now, and we'll try to understand what are the different aspects of this PCB designing, and let me try to perform. We will try to understand the different things, right? See guys, let me tell you one thing, because many of the messages I am seeing over here in the chat, right? We haven't received any kind of a material relevant to this one, right? We are trying to put all the materials together, and we will try to give it at once, because it may create a problem, because some users may get that content, some may not get, because some users attending the day-wise session, some may not attending, right? So we are trying to put it together as a single PDF, and with a single link, and that will be shared at once only, so that all the people will get access to those through drives or through the different platforms, and you will get to know about. So whenever you wanted to have access, you will get through that, right? And relevant to the certificate also can be contributed and given by the organizers, right? So that will be conducted afterwards. You don't have to bother about those things. When you are in a learning phase, your focus should be on your whatever content I am delivering here, because certificate only is a copy of that you have attended these things and these things you have learned. But until and unless you are capable of doing these things and applying the logics in from your mind, and practically capable of doing these things, which is not possible until and unless you are very focused onto this, right? Those who cares about the outcome of that, what will I get from this, right? They will never gonna get the skill set, because it takes a lot of time, right? Try to understand those things, focus on this first, and after that, the whatever process, whatever commitments are made, that will be get followed. Definitely I know about this thing, right? Going ahead with the software, what we are having, that we try to understand the software. I will open up my screen over here. Okay, so I just make a close of this. You can see. I hope you all are. Are you getting my screen now? I have launched the software basically. You can see there. This is the software I am talking about, right? So this is name of the software. You can note it down, that software, PCB Wizard Professional Edition, right? So I have opened a blank window of this. So this is called workspace for me. It is having certain grids also, right? You can follow my pointer while working with this, so that you will understand what is happening into this particular software, right? How to work with, right? I will try to, this software is actually not completely free, but the versions are also free, so you can download it, or else I will share it afterwards, so you can work on that. From that, so you can get this particular software I am teaching you now is more than 13 years old version, and it is given by my HOD at that time when I was in diploma. That's a very long story, because for my final year project, they were wanted me to have design of that PCB to be made in the college itself. So they have given me access to this software, and they have given me the setup file of that. And from that day till today, in my own project manufacturing also, I am making use of this particular tool only, right? So with the same thing, because I have certain connecting with this particular software, and it is easy to understand, I would like to introduce this software to you, because as a beginner going into more complex design software at the first time make you confused. Let I wanted to make you aware of this software, so that from the start you can understand the basic concept, and then later on in the session I will teach you the professional editors also, right? So you will get to know about both the things at once. The first thing is what the softwares are, what are the different PCB designing concepts are, that I will explain you in this one. And after that I will explain you about the professional type of software that will also play very important role in creating the additional advanced designing by using the professional editors. This is also a professional one. We'll try to make use of the circuit, right? So let us see what is there in this circuit designing software. What are the different options provided by them, right? Yeah, this software is can be downloaded from free also. Free versions are available, but it is for limited period of time, right? So if somebody wants, I will share it on my drive. You can download it afterwards if you wanted to get it from my side, right? Or you can directly Google it and download it from the website also, from PCB Wizard's website. They gives you the student version copy also as a free of cost, right? Or you can download the crack versions also, but I would not recommend the cracked version because it becomes an unprofessional one. But working with the free version, it is always preferable, right? You can make use of free versions now, because it is providing majority of things as an accessibility to the students and educational institutions. So you can have that access from free versions also. For a learning purpose, free versions are okay, right? So let us try to start with. So this is the first title bar of this particular software. Follow my arrow onto the screen, so you'll get to know what I'm trying to say about. Then you can see the first menu. This is the menu bar. This is a particular menu bar, right? Inside the menu bar, there are several options are available. There are several options are available, right? So in that case, let's say in menu bar we can see different applications, right? Just like creating a new file, saving that pure file, right? And having different documents you have created, right? So it's up to you that which particular area you wanted to go and have access to the different files as per your requirement. So you can have choices from file menu itself, that what you require, right? So we will try to the file menu in detail, and then later on one by one we will try to understand the file menu, then edit menu, view menu, insert menu, then tools menu, window, and help. I will try to give as much as detailed possible in this session, and later on we will discuss in the further session only, right? But we will start with this part of this software menus. Okay, so coming back, so first menu, you can, I hope you are able to see the menu I have opened, right? So this is the first menu is new. For opening the new file or a new project, you can say Control plus N also can be utilized as a keyboard shortcut for opening new file or a new workspace, right? Then open, which is help you. This is open menu, Control plus open, right? and after that, to this open menu option will help you to open the recent files, or you have whatever you have created. And close button is there, which is similar to this close button or this close button, from where you can close the existing file, right? Then after that, save option is there, which is similar to the any of the editor one, that is control plus S also can be utilized for saving that one from the design into the folder wherever you want, right? Then there is a called save as option, right? Which can help you to save your file with the different extensions, right? Wherever you want in different folders, let's say, that can be saved as. If you wanted to protect your document, then you can protect your document from here. You wanted to preview this design in your browser, you can have the availability in browser, you can see to it. Page setup, what type of page you wanted to get to for printing, then you can make the page setup over here. Print facility is also there, right? So in print option, there is option called control plus P. If you are having a print option, control P is the button you can make use from the keyboard. If your printer is connected and you wanted to take a print of your circuit, you can make a control plus P. If you wanted to make the artwork print, right, you can make that artwork print from this particular tab, so that only the artwork will be printed. Then if you wanted to work on the print solder side artwork, then you can click onto the solder side artwork, that means the bottom side of your PCB, right? Then if you wanted to have component side artwork, that means the top side, right? Then silk screen artwork is also there. In the PCBs, we might have seen the PCBs, right? So in that PCB, there is something is printed with the white ink, right? So that white ink is nothing but known as the placement of component ideology is given into that artwork. So that is called as a silk screen, right? And after that, if you want to make the mirror of the PCB, let's say if you wanted to make the mirror of the PCB, because there is something called positive PCB frame and negative PCB frame. If you are working with the ultraviolet based PCB fabrication process, you need to have a positive and negative of that your PCB film, right? Artwork need to be get inverted, right? So in that case, mirror PCB artwork is required to be get created. So at that time, mirror PCB can be printed from here. And invert PCB artwork, if you wanted to make inversion of that, let's say the track are in certain color, and if you wanted to make it invert, you can make that invert. That means complementary thing. If you wanted to do, you can make it there from here, right? After that, you wanted to mail the particular file directly through this software itself, you can do it from here. From the properties, you can see the different title to this particular project, subject of that particular circuit, author of this particular circuit design, for which company this particular circuit is made for, category of this circuit, keyword related to the circuit, any comment you wanted to put inside for user understanding, or any link you wanted to provide here for the user access, that you can give it over here inside the general tab, right? Inside general tab, you can see that untitled, type of PCB wizard document, location, size, everything is given. So currently we are using an untitled project, right? So if you provide this one title, you can have let's say title is let me tell sample PCB. I will try to see, let's say PCB1 author, let's say for this design I am giving my name, company name I am giving over here, right? Like this. So category manufacturing, right? Then keywords, any let's say I can use a simple PCB keyword, anything, right? Anything I wanted to this is for sample design purpose, right? So I can write anything or any link I wanted to give it over here, or anything I wanted to give, I can give. So I can click it over here, right? So like this, see, untitled sample PCB, you can see over here, untitled file sample PCB, right? So inside the properties, once again, if I goes, you can see my summary about this particular project, right? Now let us try to understand the another menu of this software, that is edit menu. We will repeat this if anybody has left this concept. I hope you all are getting and my speed is okay with you for understanding this. Let me know in the chat box, because this is the new thing for you, right? And anything left for this, let me ask for a repeat. I will try to repeat, right? Okay. So in edit, we have some option like can't undo, that is control Z, right? Redo. Then nowadays, now these particular 4 options are turned off because I have nothing created in this workspace, right? So whenever I have created something, it will help us to do control Z and control Y to redo and undo, cut and paste. Let's say I have placed one component and I wanted to make a copy of that component several times. So instead of listing it from the library, I will make a copy of that component and place it several times whenever we want, right? After that, there is another option called as a paste. So whatever content I have copied, whether it is a text, whether it is a component, whether it is a rail, or whether it is a design of any circuit or a group of circuits, I can copy and paste it by using a shortcut control V, or by clicking from edit to paste. Anything I wanted to delete from this workspace, I can make use of delete button. Then if I wanted to delete any page, I can delete page by this. I wanted to highlight any text, then I can highlight the text if I have selected any text into the design. I wanted to make a selection of all the components, I can make use of control A as a shortcut. And if I wanted to make it by using the cursor, I can make this select all. For that, I have to drag my cursor. Then clear selection. If I have, let's say I have selected any area, I will perform this also. Don't you worry about. If I have performed this area and I wanted to clear the selection, I can make use of this particular button. And after that, in edit menu, there is another menu called layers. As I stated in the PPT, there are different layers of any design. That means a graphic background, foreground, circuit diagram, real components, solder side, component side, both side, silk screen, right? So there are variants are there in the layers. Any PCB design, there are different layers are there. So whenever we enable any particular of this, because now I have enabled this graphic foreground, right? So this layer is default, right? So let's say symbol. What are the symbol? If I wanted to make any symbol or break any symbol, I can make it here. Edit any symbol, add to any library, I can add my new symbol, right? But that is for the advanced users. I wanted to fix it or insert any pin, then I can make it over here, make it a label, right? So many things are there. Let's say I wanted to make arrangement of any part of your circuit component. Let's say I wanted to pull onto the grid. I wanted to bring that layer forward, component forward or backward, or align that component, rotate that component towards 90 degree or right or left. I wanted to make the mirror of that particular design. I wanted to make a group of that certain elements. I can do that, right? If I wanted to ungroup that components, I can make that from this. So many options are available in this to perform different things, right? So let us first we complete with the menu, and then we'll perform certain things with this one. So we'll have a clear understanding about this particular utilization of menus, right? So the first one is view. View means what? Basically, what I am looking here inside my screen is a normal view, right? You can see here the normal view is already selected. Then there is another view that is called page layout view. You can see here the page is defined, right? So you can see this is the entire page. You can see you are getting a page view, right? But I want a normal view. So this is how the entire area is available for me to design, make the design inside, right? So after that, go to, right? Go to option is available. Let's say I wanted to go to the home page. Let's say many pages are there and I wanted to go to the home page, right? Alt plus home. If I have dragged my page somewhere, right? So I can click it here so that my page will be get setted and I will get to a home site, right? If I wanted to go back and forward, I can go from here, right? I wanted to go to the background, I can directly go to the background from here. I wanted to ignore the background, I can ignore the background from here. So which particular page I am talking about is untitled page, because this is the untitled file I am working with, right? So whenever I assign certain name to this file, because I have not created any project into, now not saved until this one, right? So I need to save it before, then only I can do that. After that, toolbars are there: standard toolbar, formatting toolbar, author toolbar, navigation toolbar, style toolbar, toolbox, status bar. Let us try to see what is standard toolbar. Let's say something was hidden here, something got disappear. So because that menus are from the standard toolbar. Let's say standard toolbar is having a open menu, right? Open option is given over here, save option is given over here, and in a symbolic format directly shortcuts are created. So either by clicking onto this button and this button, you can open and save your file. With the print, you can have access to the menu of file, right? The files menu. These are the some standard buttons, because delete, cut button, copy button, paste button, undo, redo, right? Select the cursor, select the tool, or you can say magnifier, zoom tool. You can say I have that zoom tool, right? So if I scroll it, you can say scrolls up, scrolls down. If I wanted to zoom it, I just have to click it. You can see this is zoom in. If I right click, it goes to zoom out, right? So let's say this becomes small. Let's say this is how these things are working, right? By which you can make work. Delete button. Let's say this delete button is for the same what we have seen in this delete one, right? So this is also available in shortcut format here, right? After that, this is a rail, or you can call track, right? Either it has a shortcut also, that is F2. You can say, you can take your cursor, it's written over here, F2 is there, right? So by pressing the F2 also, you can get the track which you can draw manually for your component board. So we will try two methods over here. एक automatic routing, in which the circuit automatically get created by the software as per the accessibility of this particular software design settings, right? And another is manual manual routing. That means you have to draw the tracks manually as per your requirements. So both the things can be possibly done in this software very easily, very conveniently. We can do those things, right? So the tracks can be implanted by using this track option. Then the pad is there, that is shortcut is F3, right? This pad is nothing but the point where we used to place the wire, right? Or you can say the components need to be get drilled, right? So this is what the pads you can place onto your PCB, so that the component can be get mounted onto it through the pads, right? You can see it has different options, different pad options are there, right? So this kind of an it looks like, right? I don't want this, so I delete it, right? After that, if you wanted to have a circuit board area, you can click onto this circuit board, right? So circuit board area looks like this. Then copper area, if you wanted to add into your design, then from these one you can add the copper area. If you wanted to have a label to your PCB, let's say you are designing any project and you wanted to print the name of your project PCB or your name on that PCB background by using any text, right? Any text you wanted to print, so that label can be typed by using this copper label, right? If you wanted to rotate the component, anything, you can rotate it from here, right or left. And from this briefcase icon, this is what the source, where you can have either the circuit symbols for designing the circuit, and PCB components for placing the component directly for manual routing, right? So one is for automatic routing. You will use the circuit schematic you can create, and from there you can jump directly to the auto routing. But in case of PCB components, you have a choice that you can have this kind of an components. You can see here, these are the components. You can say, if I use this as a circuit symbols, you can see the circuit symbols are available. Any of these components I can choose and place into the workspace. So I can create a schematic diagram of my circuit design, right? So this is how the things are working in a PCB wizard. The options are given, right? So we have done up with the file, edit, view, right? So let's go for insert, right? Let's go for insert. Yes, Mr. Dilip, what happened? Let me see your chat. So pad is basic. You will get to know when I will put the circuit in design. You will get to know about what is pad and how it looks like. When actual world we will work with the example, then you will get you understand. I'm going to repeat everything when I create a circuit. That time you can note it down, right? Please note this point. I will come back with the example. At that time you will get to know about everything. I'll just giving you a brief about each and every menu now, so that when I work with, you will have an idea about what I am doing exactly, right? And that is what I am telling you, each and every menu, right? Don't you worry about. So we have seen this file, edit, view menu, right? Now we'll go for this ahead menu of this, right? Because gallery, either you can go from here, this briefcase, or you can have this access from gallery itself. So gallery is having that circuit symbols, PCB components, right? So both are ticked now. So if I wanted to make it disable to appear, I can untick both, so that you can see both the windows have disappear. Now I wanted to display something. Let's say I wanted to have certain background color. I can go to the background color. I can make use of custom color. You can see the color has been changed, right? So I don't want that. So let's say I go to the background and I try to use the default color only. So the default color is, because this will work very well. Somebody has a choice of color. So if anyone wants to have a background, they can add the background color from there, from the display. Let's say if you want to have round corners, if you wanted to have round corners, then in that case the corner will be get presented at the round corners. Let's say if you enable this round corner to the component, if you wanted to see the pin numbers, then you have to enable this pin numbers for your ICs and your transistorized devices or components. Bottom copper, if you wanted to see the bottom copper, you have to make enable bottom copper. If you wanted to see the top copper, you have to make it enable top copper. These two things are very important in double-sided PCB. These two things are very important while designing the double-sided PCBs. Then copper areas. In the free space of your PCB, if you wanted to add certain copper areas, you can make enable these copper areas. If you wanted to print certain text information, where to put the components and that design, then you can enable this silk screen. Then the automatically the silk screen can be get plotted onto the design. Components, if you wanted to look around, then you can enable this component by taking out here. If you wanted to look out for wires, then wires also, nets for jumpers. If you wanted to see the X-ray mode, you can go for X-ray mode. And if you wanted to make some customization, that is what is the color coding required for this, you can click onto this and you can change the color. That means it's up to you how you wanted to make the customize your page display, basically, right? It's up to the user. I'm currently using the default setup which is coming from the manufacturer of this particular software. So there is no need additionally, but some people are having kind of a choices of color, and they use different customized color coding for their designs. So they can make use of that display in a display in a different manner, right? So it's up to you what to do with the different aspects of that customizing the display and background pins and everything, right? Let me try to go ahead in the menu style. Let's say in the style, what exactly you wanted to see, right? Real world view you wanted to see, artwork you wanted to see, unpopulated device or prototype, solder side artwork, component side artwork, full screen artwork, classic artwork, or many things are there. You want whichever you wanted to create or something like that, you can add a select from here and make use of that. It's up to you. The same things are available over here also. From here, that styles you can select what exactly the project should look like. That is called as a style. What you wanted to make observe from your project, that is called as a style. Then if you wanted to give a header or footer to your file, then you can give it from here. That whatever, let's say left, center, or right, what you wanted to write in that header, footer, right? Footer is given at the page down below that page, right? Header is given applied at the top of this page, right? What will be the font size you wanted to choose, right? What fields you wanted to write, this one, right? So everything you need, you can make use of and work with, right? So these are the few menus by which you can simplify your accessibility in this particular project. Then coordinates. Let's say what coordinates you want. Origin. If you wanted to change the origin or show origin. Let's say I click onto the show origin. For my page, this is the origin of my page, right? So at that point, it will take you. Let's say if I wanted to work in the millimeter range, I can click onto this millimeter. Let's say if I wanted to work with centimeter, let's say it will be in a centimeter. If I wanted to work with, let's say meters, it will be that the blocks differentiation will be in the meters, right? If I wanted to work in inches, right? So accordingly, the things are changed, right? So let's say this is the smallest part. Sorry, once again. So this is what somehow you can see these the different views of this. This is a grid. Basically, this is the grid. And what is the size of that grid? If I wanted to make this grid hide, see, this is a plain area you are getting. No dots are there, right? Earlier we have seen that grid is present, which will help us to drag and drop component, draw the tracks with the help of that alignment of grid, right? But in this case, there is nothing. So we are free to draw, right? So without the help of grid, if somebody wants to work, they can go with the grid. They can go here and choose that show grid. So I can again I will get to you this one as grids present in this one, right? So now after this you can have the grid points to be in different dimensions, right? You can say you wanted to make use of minor one. Let's say I will choose the 0.025. If somebody wants to make use of 0.1, they can make use of. If somebody wants to make use of, let's say 1 mm, they can make use of 1 mm, right? According to your choices of grids, you can make about the things. and accordingly the things or the grids will appear in your workspace, right? So depending upon your choices, these grids will be appear. It's up to you where you are flexible to work with. It's not mandatory to have that grid, but I will keep this for 0.1 inches. So let's say this is what the 0.1 inches basically looks like this. So now after that, show the special characters if any you wanted to insert, right? Show page guides, right? So if I wanted to get a show page guide, so then in that case you will get to that. Then if I wanted to zoom it, right, to the actual size or full page size, so I will keep it to the full page. So you can see, you will get this full page now, right? You can see the footer is written. That footer is having untitled, some sample PCB is written as page 1. This is the first page of this particular file, right? So if I wanted to view zoom actual size, see this is the actual size, right? You can make a change difference in this, and you get to know about this thing, how this particular software grids are utilized, right? In that zoom, I wanted now at current time, the zoom of this particular thing is how much is the zoom. I will try to tell you. Let's say this is currently 100%. Yeah, this is actually 100%. But what if I wanted to have it to 75%? You can see this is 75%. And what if somebody is not having much bigger monitor? If they wanted to have 50% of zoom, then this page looks like this, right? And what if somebody wants to have let's say 150%? This is a much bigger zoom. Either you can go from here and use the right and left button for applying zoom in and zoom out, or you can go to this zoom from here itself by using shift control L, and for actual size, F8 is the option. So you can press the F8 button. This is giving you the actual size of your page, right? So I wanted to make use of full page. Let's say I will go for this one with the 100% and full page. Let's say this is the full page basically, and whatever after that I wanted to do, I can do it with this, right? So this is 98% now, right? And I'll go with this. Let's say now I will do actual page. Okay. So this is how the things are carried out. You can have an access to this, right? So if I wanted to make, let's say this is about the view menu, right? Different aspects of operating with this particular software you need to learn first before making use of this software, right? The final part is creating a project. Right? But before that, you should understand different menus, because while working in that project, I will use directly and you will not understand, right? So I want you to understand the menus concept first. Then I will create a project, and while creating the project, whichever tools I am using, whichever menus I am accessing, simultaneously you will get to know about those things, right? So that afterwards there is a insert menu. In that insert menu, if you wanted to insert a text box, let's say somebody wants to write something, so let's say this is a text box, you can insert, right? So I can write, hi, this PCB, I can write it here, PCB is for demo purpose. You can write it down, right? So this becomes a text. Whatever print I wanted to print as a text for this particular PCB, I can put it there, na? Because sometimes it becomes necessary to have certain comments and text relevant to the use of that particular schematic for you better user understanding, right? You need to have that text to be added. Then if you wanted to insert the table, you can insert that table also. Symbols that will be get that symbol and table will get enabled afterwards, but currently it is disabled for some because I have not used that one. So pictures, let's say if you wanted to add any pictures into your this circuit board, currently I am not having any clipart downloaded because I have no use of it. But if you wanted to insert any picture or symbol, you can insert that picture into, let's say any thing, let's say related to this page I wanted. So see, I wanted to use this particular picture, I can make use of, right? So for referral purpose also you can make use of this kind of things in your design. All right, so it gives a clear clarity about the design. To that, you wanted to draw a line, something like that. This is how you can draw any line, let's say, right? For any object, any creation you wanted to create, you can create it, right? Because it requires a lot of things. Let's say, see, this is how you can. I have put it select all, delete. Okay. So after that, insert in that picture. If you wanted to draw a rectangle for having a clear cut idea about how much area I will occupy onto this particular page. So this rectangle is the component basically, right? And I wanted to work within this rectangle. If I am working manually, I can design the border to my PCB by using this component, right? And then I can send it backward or forward, arrange from here, right? So you see this, all the menus got enabled. So this is how we can work with. Then inside the picture, again another thing is that arc is there, right? Chord is there, freedom is there, and scribble is there. If you wanted to scribble something, let's say I wanted to do something like that, whatever movement of cursor will be happened, that will be carried out as a scribble, right? So inside the insert, there is called PCB component, right? So in from the gallery, you have a choices. Either you can go to the gallery from here, or you can go to the PCB components. Let's say power supply, let's say connectors. I want single inline connector. Let's say I want 4-pin single inline connector. Let's say it's done, right? So how many pins are there? 1, 2, 3, 4. 4 pins are there, right? So any component I wanted to get added from PCB components, I can add it here. But that component is a PCB component. But if I wanted to add any circuit symbols, let's say power supply, I wanted to add battery. It's a battery, right? But other option is I can go from here, circuit symbol. Okay, I wanted to add this one. I wanted to add a battery. Let's say, you can say the battery. This process and that process both are same, right? So it's up to the user how much time it needs to be get utilized in designing of this particular circuit diagrams, right? Depending upon that, they may choose where to get from, right? So definitely, yeah, we can change the value. We will see each and everything inside this particular session. You have to have some patience. I know if you are getting some questions, definitely that means my session is working very fine, because you are getting queries. Your mind is getting some questions. That means you are trying to get focused and try to understand. But let me tell you, each and every thing is planned according to the timing of that particular delivery, right? So requirement of that particular implementation. So you have to have patience, because in upcoming sessions you will get all the answers of your questions, right? Don't you worry about much about those things, whether I will answer your questions or not. But I've tried, because whatever questions you ask in the first session, that are already planned in the second session of that. For that, you have to be consistent while attending this session. I hope you all are consistent and attending the sessions from day one, right? Okay. Coming back to the insert, after circuit symbol and PCB components, we go to the track. See, this track and this one is the same one. Either you can choose it from here, or you can have from here itself, right? And then this anchor also you can make use of. Page also you can connect it with, right? You can add the pages, something like that. Insert new page. Let's say you can add, let's say new pages, number of new pages. I want one new page to be inserted, right? Before current page or after current page. I want after current page. Okay, right? So if I wanted, this is the first page, right? And you can see at the bottom there are 2 pages. If I go to see, you are currently on the last page of the document. Do you want to insert a new page? Let's say the page 2 of 2. I don't want any, right? This is a page 2. I wanted to go to page 1. this is the page 1. Let's say I will zoom little, I will just try to make it smaller so that you can see there are 2 pages in my project. This is page 1 of 2. You can see this is page 1 of 2, right? And if I goes here, you can see wait a minute. Okay. You can see there is called page 2 of 2. That means my project is having 2 pages, right? And let's say I wanted to let's go for this one, insert pages. I have inserted that pages. Let's say, and I wanted to make any of those pages get closed, right? So let's say, do you want to save changes you have made in the untitled? Because I have clicked onto this one, right? I don't want to save, right? So if I wanted to save any, then I can click onto yes. I don't want to save, so I have deleted that one. So I come back to the page 1 of 1. Let's say, right? So likewise, you have a variant scope over here, right? So what layer is there? This is a graphic foreground. You can see here in the back bottom that graphic foreground. Grid size is 0.1 inch. How much is the zoom of this current project? 100%. And how it is status is ready, right? So everything can be observed from the status bar at the bottom of this particular software, right? Then after this insert menu, the third one is the tools. If you are writing something and you want to let's say spelling, right? You wanted to use some spellings, right? So in that case, you can have this F7 option is there, right? Spelling check is complete. Something is written over here and you wanted to check for the spelling, you can go there and check for that. If you wanted to convert that your schematic to the board, you can click onto the convert design to printed circuit board. This will help you to automatically create your design. It will help you to automatically create your design. And report, insert part list in the report. You after designing, you wanted to create the part list for sending it to the component purchasing, right? You can easily create the insert part list from here, right? And other than that, if you wanted to put the bill of material reports, right? So the bill of material report is also can be made it from here. How much quantity, how many components are there, right? What will be the price of it? Everything can be made out of the bill of materials ready from here, right? Then auto route all nets, interacting routing settings, everything is available for auto routing concepts are there, right? Then CAD CAM, whether you wanted to have CAM data or export for Gerber file for sending it for the manufacturer, right? Everything can be done over here. And libraries, let's say if you wanted to add up some new components to the library or install new library from the internet, you can add up to here. You can have add library here. Just depending upon you what options you wanted to do it with. But it's mostly the all components which are essentially required for a basic PCB design purpose are already given inside the software with this one. Let's say if you wanted to set a password for it, let's say allow you to password protect the application settings and options, again unauthorized use. If you wanted to make use of this to protect your accessibility, you can assign the password for these tools, right? And there are certain options are also there. So you can see the options, right? Preferences, measurement of units are in inches, remind to save document. Whenever you wanted to close the software, this will remind, right? Spelling, symbols, layout, database, whichever you wanted to use single click object creation, right? You wanted to use a single click, right? Symbols, what type of symbols you wanted to make use of. Always print circuit diagrams in black and white design. right? You can show crosshair cursor when drawing wires. Anything you wanted to make it enable. See, the digital components are American design they are following. Which one? American NC. Analog components following European design. That is DIN. Layouts. What type of layouts? Component packages के type पे ऊपर आएगा, right? So the style is normal component outlines, normal recommended basically, right? Database क्या रहेगा? So whatever the suppliers database will be, 10 pin header, 14 pin header, cost, whatever is provided here, that will be get. If you wanted to edit that one or add anything or import or export anything, you can do that, right? It's up to you what things you wanted to get into depth, right? Up to your own understanding. Accordingly you can go and try to understand those things. This windows will help you to open up new window, right? So let's say this is basically I tried to have, let's say this, you can see these are two windows. This is the first project, this is the second project, right? So it's up to you. Within a document you can open up the two windows. I have currently the design of PCB is depending upon the application. If you are a manufacturer of a PCB, then the design is sent by the user, because you take order from the user or customer and you give it them that fabricated PCB. So you don't have to make any changes. So they will send you the copy of design. You have to make it print and accordingly whatever process is needed, you have to carry it out in your fabrication industry. But if you are own customer itself and you wanted to make your PCB, then you have to carry out the design, you have to make the bill of material ready, you have to draw the layout, you have to send the Gerber files, everything. You have to print that circuit, right? Or if you are a fabricator plus manufacturer, then all the things from designing to the processing of fabrication, everything need to get carried out at once, right? That depending upon the user, either it is a only customer, either it is a only fabricator, either both fabricator plus customer, depending upon both factors are included, right? It's a choice. If you are doing a fabrication business, then either you can sell your designs or you can ask them to provide their designs and you can go ahead with the fabrication, because it will save your time. Because if you are manufacturer and you make the design and it's not so reliable, it will gives you a very bad impact on your customer if you are not good at your design, right? No, definitely there is a scope of fabrication business, but nowadays those industries of bigger gadgets, they are having their own fabrication units, right? So you can apply for a PCB designer's job, or you can say PCB design operators, or you can PCB designer vacancies, right? But if you wanted to start your fabrication unit and take the contract from the several industries, you can also have an opportunity, but very limited opportunity is there, because new and technologies are incorporated in nowadays for industrial processing, and many of the things are performed by using the automation technology. So the new age will taken out the uh, older processes, and that may leads to lagging of this fabrication units, individual fabrication units. But for a smaller level, you can start your PCB fabricating unit also, and you can serve to the nearby industries or to the colleges, or you can say to the college students, academicians, or researchers. You can help through your units. But there is low scope for having a customers, but you have to make more interactions with your users to get newer customers every time, because that is the only key to run any business. Because for few customers you can't invest a lot of money and lot of time onto, and lot of components and things are also required for professional fabrication, right? So it is little bit of costlier. So it's a choice of a user whether to go for that or not, right? So it's depending upon user to user decisions, right? Whether to go for that particular things or not, right? So decide accordingly. It's not always suggested to go for particular industry, right? But if you wanted to be in a research area, work for a research, then work with your own laboratory, where you can teach the students, right? Like me, I'm teaching the students always, right? And also I am making a fabrication of that. But I used to make a single sided PCB more majorly, right? For my PCBs, and whatever I require additionally, I brought it from the other fabricators or market fabricators if I need to design any complex circuits, right? So depending upon the user's mindset and user's choice, they have an options available to them, right? As per my because I used to carry out some operations in my lab, right? So at that time I used to integrate certain components. I work with the general purpose PCB for before making the actual PCB. I work with the breadboard, right? I test that component. Then I try that to make by using the general purpose PCB. And if everything is working, then I make that circuit into the schematic, right? And once I make the schematic, I make that layout ready for fabrication, right? And then after fabrication, I used to solder it. And once it is soldered, then my design get ready for as a prototype, final prototype. And once it is final prototype is ready, carry out some uh, you can say calibration onto it, carry out some tests, and my final product is ready for delivery purpose, right? Like that you have to carry out, because it's completely a cycle of any product designing, right? So likewise you have to also follow these things, right? Let me check your question. What is that? Can you test any component while it's mounted on PCB, whether it's in okay condition or not? Let me tell you, if your component, yeah, in some cases you can do, but the condition is that because in some circuits there are electrical charges are there, right? Some components hold the electrical charges, so it is not recommended to test on board, because if you are you are using the ready-made PCBs like motherboard or television set unit or any controller board which is readily available, and if it's showing some error, you can test it using the multimeter, right? But you have to ensure that what type of board it is, and whether to you have to bifurcate it from the electricity or not, because what happens is if you try to connect it in the live circuit, right, it may create some shorts in that particular circuit, right? So at that time you have to take care of these things. As per the condition, you have to take a decision whether to directly test it, or if it is not fabricated, then better always it is a better suggested that you should firstly test the component, then test it with the breadboard, then go with the general purpose PCB, try it for it, and if everything works well, try it with the simulation also, and then go for the fabrication of that particular circuit. So it has a lesser amount of failure rate in the practical design, right? So these are some of the points which one should have to consider while designing of a PCB. And when we design the PCB, this kind of an effort if we take, it will save our money, it will save our repetitive time which is get utilized if it PCB got failure, right? If it is getting any errors into that, or the circuit is not working, right? So maintenance cost also get lower if this kind of an precautionary measures are taken before thinking about the output of the final product, right? So you have to start from the day one. You have to visualize that part, that how your system looks like. So we have that philosophy, that theory process concept, that every design comes firstly in your mind, then in on the paper, right? Firstly in your mind, then in on your paper, and then you create inside. Once that design is mounted on your paper, then you are able to get that design into the real world, right? So try to think over on your design in a practical ways, how that aspects of that system looks like when we see any of the objective of implementation of that particular system, right? So this is what basically for the today's session of morning half, right? In the afternoon half, we will see actually what how the system is designed, how the schematic is designed, and how schematic and layout is carried out, right? So we will get back at 2 p.m. sharp, right? So I hope you all liked my morning session, right? This is up to for the first session of PCB designing. Hope you all like this session in the for the this time, right? We'll meet afterwards, but before that you just fill up your all forms. Attendance link is provided, I think, with your coordinator, right? So you just fill up that things. Yeah, we have to print that mirror image on diagram on PCB plate. So just now I am yeah, and I definitely I will tell you how that animation of that PCB is look like, and how the real world PCB when we carry out design. That you have some you have to some have some patience, because that will be in the second part of this session, right? Today, day after tomorrow also we will see and focus on to these aspects. So be present in the sessions so that you will get more and more about PCB designing. Firstly, I tried my best to cover up the basic concepts of this, and I hope you all have understood these things. Okay,
Uh, Hello. Uh, Thank you, Avdut sir,
welcome, sir.
for giving such a wonderful session on PCB designing. Thank you so much, sir. All the participants, it is to inform that afternoon session will start at 2 p.m. exactly. Afternoon session will be starting at 2 p.m. Is it okay, sir, Avdut sir?
Yes, 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 yes.
Okay.
Wow.
Thank you, everyone. Please fill your attendance form, and those who have filled, they can leave this meeting. Shweta madam,
Yes, sir.
madam, please close this meeting after 5 minutes.
Okay, sir. Okay.
After 5 minutes, please close this meeting.
Okay, sir. Okay.
Sir.